Hello, everyone. My name is Laura Shrake. I am with the Council of the Great Lakes Region. Welcome to our monthly webinar series. We've been running this webinar series as part of a larger business and sustainability network, an effort that is supported by the Herb Family Foundation. And it is really great to see our audience growing through these virtual convenings. In addition to our webinar series, we also convene through our flagship event, the Great Lakes Sustainable Growth Forum, which was previously known as the Great Lakes Economic Forum. It is an in-person conference, and this year it will be taking place June 25th to the 27th in Toronto. And I will put a link to it in the chat shortly for more information, and hopefully many of you will be able to attend. It's a great opportunity to network and discuss many of the issues and the pressure points that we touch on during our webinars. These convenings, both virtual and in real life, are important for finding solutions to many of the region's challenges. The Great Lakes region has immense environmental value. As many of you will know, it is home to one of the largest freshwater systems in the world. And we are fortunate to have such valuable natural resources. There is so much we can learn from the environment and the nature all around us. So today's webinar will take us into the practice of using nature to inspire design. And our speakers will shed light on the practice of biomimicry. So over the next hour, our panel will share case studies of biomimicry and examples of nature-inspired design. And we will get a better understanding of why this kind of innovation is important. As I mentioned, the Great Lakes system is one of the largest freshwater systems in the world. It holds roughly 20% of Earth's surface freshwater and 84% of North America's. The region's 8 US states and 2 Canadian provinces are home to 107 million people and host roughly 51 million jobs. Collectively, they make up a strong regional economy that is considered North America's economic engine. And with major industries, esteemed universities, and research institutions, innovation is ignited and cultivated across the region every day, and the Great Lakes region is poised to lead the transition to a sustainable future. The Council of the Great Lakes region knows this to be true, and as a result, we are working with stakeholders across the binational region to solve for sustainability through our programming on water stewardship, circular economy, and decarbonization, to name a few. If you are interested to learn about the Council's cross-sector programs and how you can get involved, please do reach out. We'd be more than happy to share information with you. But now let's start talking about some of the innovation and the sustainable solutions that use nature as inspiration. So with us today, we have 3 great panelists who will share the spotlight. They will introduce us to biomimicry, share the process of nature-inspired design, and present some examples from the region. We have Carol Thaler and Tricia Brown, both co-directors at Great Lakes Biomimicry, and Peter Nivorosky, a co-director at the University of Akron's Biomimicry Research and Innovation Center. So we'll hear from the 3 of them with their presentations. After they have presented, we'll use the remainder of the webinar for Q&A. We'll address a few questions that have come in advance with the registrations. You will also have the opportunity to put forward questions using the Zoom Q&A box. So I guess to kick us off, I will hand it over to Carol.
Huge. Hey, everybody. Let me get the text started here. Is it working? Okay, let's start. All right. Abby, Laura, I guess hopefully the tech is working well. I am Carol Thaler. Tricia, Peter, and I are coming to you from the southern shore of Lake Erie, where we are getting ready for the total solar eclipse that's going to be coming by. So hopefully some of you in the audience will be able to experience that as well. So we're here today to talk to you about how to innovate learning from nature. And the first thing I want to do is tell you about what's going to happen in the next half an hour. So we're going to introduce what biomimicry is, um, give you some examples, talk to you about the process of biomimicry, because you can't just go outside and say, okay, nature, tell me how to do this. But there's also a mindset that you need to be able to set aside sometimes your education that said, this is how you do something. We need to open the aperture a little bit for those photographers out there. Open the aperture a little bit to see what we might let in and what we can learn from nature to invent new things. So biomimicry is innovation inspired by nature. It's built from the Greek words of bios, meaning life, and mimesis, to imitate. You might also have come across these other words. Sometimes different cultures, I know in Europe and Germany, bionic and bionics is what is used, but it's all the same thing, innovation inspired by nature, or you could also say inspired by biology. And it's an interesting way to look at the life that is around us. It really is 3.3 billion years of research and development. Everything we see around us has survived eons of stresses, and it's figured out how to live in the context of Earth. And for humans, it means we need to make the choice to look at biological systems, to look at biological forms and processes as well. So Janine Benyus wrote a book in the late 1990s, just sort of bringing this idea of learning from nature into the modern age. And one of her quotes that I like the best is thinking of nature as a teacher rather than a warehouse where you extract what you need is a really powerful thought, really powerful act. So why should we look to biology? Like I noted before, biological strategies have evolved to function with efficiencies in the same context that humans must. And function with efficiency is really important because any extra material or energy that's used, or if an organism needs it, it dies away. If you need too much energy, you don't survive. So just what is the context of Earth? We have lived in this context our whole life, and it's good to stop and just think about what is the space that we're living in. Biology runs on sunlight, and it's the current solar income. You know, when we drive around, we're actually burning ancient sunlight, if you think about it. We're putting back up into the air things that have been buried for a long time. And maybe we should find a way to do something different. You know, we live in a water-based chemistry bubble, I should say, or Earth is water-based. Gravity is universal. A tree has a structure to it so that it can, with or against the forces of gravity, offer the leaves up to the sunlight to create energy. There's always change on Earth. The weather's changing. The amount of sunlight that hits the Earth changes. There's limits and boundaries. You know, a plant can only grow in a certain temperature. So that has a limit on what it can grow. And then down to the cellular level, the cell has a membrane that creates a permeable, but a limit. And there's cyclic processes. There's the seasons, there's night and day, there is the tides. Those are all things that happen to every living thing. And we need to learn how to adapt that. So another reason to look to biology, it's a tool to reach sustainable solutions in materials and manufacturing processes, communication, and systems design. So we at Great Lakes Biomimicry are looking at biomimicry to be a basis for economic development that's friendly to the environment. I spent many years in public service in the community planning realm, and there was always like, oh, well, we have to develop because otherwise we won't have jobs. And, one of the reasons why I'm working in biomimicry is because I want to have jobs, but I also want to have what is produced to not be harmful to the environment. And when you look at this wave, makes you realize, looking to biology, we might be able to do better. So let's quickly talk about some examples of biomimicry in manufacturing. So what you have here is a mantis shrimp. And a mantis shrimp has a club that it uses to kill or break open the shell of its prey so it can have dinner. And that club is made from a material that is both hard and soft. The soft material is chitin, a protein, and it's embedded in a matrix of mineralized calcium phosphate. So you may have never thought about a mantis shrimp, but this mantis shrimp is a very important thing to think about and to mimic when looking at making composite materials. And there's a company called Helicoid Industries that's doing just that. The idea is that with the structure of the mantis shrimp club, it can create a composite material that has a fiber alignment that provides many benefits, including reduced weight, increased impact strength, increased toughness, and improved impact resistance. So, I invite you to look up Helicoid Industry and find out more about them as a composite material manufacturer. So biomimicry is also influenced carpet. I don't know if you've ever been around in a large space or even in an office where you see the carpet is in tiles rather than a large roll of carpet was put in. It's put in these tiles. An interface looked at the forest floor and in a riverbed and looked at the colors and how that all comes together, and it never looks like it's a mess. It just looks beautiful. And what they decided to do is make these carpet tiles that mimicked what the forest floor looked like. And what that does is when you have a high traffic area, you can pull up the tiles that are worn, put down new tiles, and you have eliminated a lot of waste because you don't have to rip up all the carpet and put it into a landfill. And the other thing about interface carpet, I believe that it's recyclable, which is really important with a lot of our materials. We use things and we hope to recycle it. But interface carpet has taken that to another level and having carpet be recyclable. So here's something that the basis of, we've got a lot of carbon in the atmosphere. And this company, New Light Technologies, looked at, well, how does nature use carbon? And they looked at the coral reef that looks at and looked at how they take methane and carbon out of the water and have made a process to make material that is taking carbon and methane out of the air. So taking it out of the air and creating a product means you have a net zero, or you're even using more carbon than you're emitting, and you're giving something for people to use. I'm excited about that one. And I know we're in a water universe here, and I wanted to just give you a couple of examples. This company is out of New Zealand, actually, and they've created a chemical-free water filtration that's inspired by forests, because forests manage a lot of water. It's a self-contained system, and mainly it's used in septic tanks. The water is cleansed by microorganisms and it filters through a pump chamber. But this ecosystem tank does it without needing large aerators to run, repair, or replace. The result is up to 90% less energy being consumed than most aerated sewage treatment systems, thereby reducing electricity costs. And here's another example. Might have to ask Peter about this. It's always good to have a biologist on your team. This is a company that is looking to stabilize what's called aquaporons to purify water. So the team is mimicking the way diatoms form their cell wall out of silica and utilizing aquaporin proteins that transport pure water across cell membranes. Their energy efficient and selective technology produces high purity grade water in a single filter pass, desalination at any scale, and removes industrial pollutants and contaminants such as arsenic, microplastic, and pharmaceutical residues. I know they're on the cusp of really making some strides in this innovation, and I'm kind of excited about them too. And we're not going to go through this today, but there is a process by which a company, a community, a sewer plant could look at, okay, here's our question. And then biomimics can help bring them through the process to find those biological models that will help you solve the problem. And Peter's going to talk a little bit about that next. All right. So Peter, welcome to my friend, my biologist friend. We'll hand it off to you.
Great. Thank you very much, Carol. Yeah, my name is Peter Navrosky. I'm going to try to give you just a very quick look under the hood of what biomimicry is, why we should be using it, for what kinds of problems, and sort of how, but it's going to be a quick look, maybe whetting your appetite for more by other means. So if I could have the first slide, Carol, please. Great, thank you. So I've sort of divided up my brief comments into three themes. We're going to drill down a little bit into the why, the motivation for biomimicry, the kind of what do we apply it to, and then how. So those three themes will sort of structure what I talk about over the next few minutes. So if I could have the next slide, Carol, please. Now, there's a lot going on in this slide, and I provided a reference down in the lower right from a paper that it comes from, a research paper. But the basic idea is if you focus on the two panels, multicolored panels on the right-hand side of the screen, a researcher named Julian Vincent basically mined biological research studies, thousands of them, as well as patents, thousands of patents. And his goal was to classify the problems and solutions found in patent database and in the biological research literature, to classify problems according to the category of solution to the problem, as well as the sort of size of the problem. That's what these two panels show. So patents on the top, biological systems on the bottom. And for reference, because this is a little counterintuitive, you can think of problems along the x-axis represented by size as problems of really small scale, like the lotus leaf as an example, which is hydrophobic and self-cleaning because it has structures on the surface of the leaf that are tiny, microscopic and nanoscopic, that provide that hydrophobicity, that water repellent nature that leads to self-cleaning. Those are problems that are solved by structures on a very small scale. On the right-hand side of the x-axis, we have problems of a very large scale. And you might think of an example of that as something like an airplane that can move things very far and very quickly, solving the problem of moving objects, materials over a large spatial scale. So the main thing that I would like you to just see in these two panels and comparing them is that engineering and technology solves problems at all length scales along the x-axis, and the different colors represent different categories of solutions. Engineering and technology solves problems very differently than biological systems. And one of the most conspicuous differences between the top and the bottom panel is the extent to which we use energy to solve problems. So you might think of this in the case of the airplane as something like the jet fuel and the cost and the energy required to obtain and then burn that jet fuel to solve the problem over length scales of kilometers. Whereas the lotus leaf at the smallest length scales is solving a problem by creating some structure with minimal changes in the DNA of the plants, which is information. So we have at the top in engineering systems, lots of use of energy, the big red swath along all length scales. But in biological systems, that red path is very small. And really, biological systems rely on information and time and space and structure in solving problems. If you'd like to know more about that, I can share the paper with you. It's rather interesting. Next slide, please, Carol. So what that last slide tells us is that biological systems solve problems in different ways than our engineering and technical solutions. So that's sort of a strong motivation that we can find innovation if we understand more about how biological systems approach solving problems that we're interested in. But it's also true that lots of different sectors of our economy and our society can use that potential for innovation. And these are just some examples of some companies that have worked with our center and with Great Lakes Biomimicry in collaboration to sponsor PhD fellows that help them tackle specific questions or problems in a search for finding solutions from biological systems to find novel approaches. So they're in all sorts of sectors, right? We have Gojo, Goodyear, PolyOne. We have the chemistry sector. We have the sector of biomedical engineering and biomedicine, US endoscopy. We have the food industry, Smuckers, Sherwin-Williams, and Tremco in the building industry. So the potential for applying biomimicry, as demonstrated by these companies that have taken a deep dive here, is very broad, and it's not limited to any particular sector. Next slide, Carol, please. So two examples a little bit deeper. US Endoscopy was interested in developing a new gripping tool in surgical procedures. And what they did is they studied the feet of birds of prey, looking at their talons, and they literally reinvented a gripping device called the Talon, which was a market leader, based on the design of the feet of these birds of prey and how they could grip fish very securely. They are also following up with that same approach now, asking questions about how the teeth and jaws and muscles of animals that are predators in gripping their prey might also lead them to even more novel designs. Goodyear, as another example, is interested in hydrophobic surfaces, not unlike that lotus leaf I talked about, but in this case, inspiration coming from shark skins, to understand how those surfaces naturally repel water and might lead to ideas for how to channel water away from the contact interface of tires as they meet a wet road. So there's a lot of potential just in these two examples, but again, that can be expanded to lots of other companies and sectors. Next slide, please, Carol. Great. So the sort of giving you a little bit of the why and the what. Let's drill down very briefly on the how. As Carol mentioned, there's a process, and I like to think of biomimicry as depending on sort of two iterative design cycles, left and right, represented by these two circles on the left-hand side of your screen. Basically, a problem serves as input on the left cycle, and that input problem is a problem that we wish to solve. We can boil it down into a technical problem, that is, what is it we're actually trying to achieve as a functional output. And then we can transpose that to a biologically specified problem so that we can search biological systems to find models in biological systems that solve that same problem. Once we have those models, we can study those models to understand how they work, how they solve that problem in a novel way, and then we can use that to transpose those mechanisms to a technical solution and get a product or a novel approach. An example of this is something like the lotus leaf on the right-hand side, which I mentioned already, has this structure, which is a self-cleaning structure because it's hydrophobic. The way that works is that rough structure, it's not smooth, repels water, which you can see is the behavior of that surface when it contacts water. And that arises from the chemistry and the morphology, but it leads to the function of self-cleaning that we see at the top. Next slide, please. Another example from the companies that we worked with, just to try to put a little bit more clarity on this with a brief set of comments. Gojo was interested in creating a touch-free soap dispenser that used less energy. These dispensers are powered by batteries. You can read about this full case study in Research Technology Management. I can provide you with the paper. But what they want to do is solve the problem of dispensing their product for cleaning hands with a lower carbon footprint. Next slide, please. And so the problem was to distribute fluid, which is the soap. And what they did is they looked to biological systems for examples of biological systems that move fluid. And they found lots of different potential models like the spitting cobra or the squid, or even some plants like the bladderwort that have novel ways of moving fluid with low energy inputs. Next slide, please. Among the full set of models that they discovered, they found one that was particularly interesting for their pump design, their redesign, and it was based on basically the heart. If you could start the animation by clicking on that, that would be great. The heart functions in a way that when the walls of the ventricles are stretched with the filling of blood, they recoil more forcefully with stored energy. The engineers were able to take that idea and develop this double paddle pump system that reduced the energy of delivering the fluid by 50%, reducing the carbon footprint and the batteries and the interval at which batteries needed to be replaced. So it was a success in translating the mechanism of the biological heart to the design of a new pump. Next slide, please. So I think those examples are meant to give you sort of a very brief look under the hood. The why, the what, and the how are all underpinned by very deep research, practice, and application that geobiomimicry can and the University of Akron's Center can help you with. And I'll turn it over to Tricia now to finish up.
Great, thank you, Peter. So after all that information, you might be wondering how you might begin to approach your challenges that you're facing in a different way. One way is to look through a different lens. So on the left here, we have a refinery, and on the right, we have a forest. If you think about it, both of these are production facilities. They take inputs, they have processes, and they have outputs. And maybe you've never looked through the lens of them as showing a forest as a factory, but it is. And there's many things that can teach us about how to do processes that are more sustainable. To help shift the perspective, you can adopt a mindset that Carol talked about earlier to prepare yourself to be thinking about this differently. The first is to be open to learn from nature, not just about nature. This is akin to the quote that Carol read earlier of Janine Benyus about not using nature as a warehouse, but as a teaching tool. So we're used to just learning from nature at school in a book, but we need to learn from nature. It's also really important to shift your mindset to include cross-cutting perspectives. That means it isn't just about engineering. It isn't just about product design. It isn't just about the singular silos that people sometimes work in for problem solving, but to include all kinds of minds at the table. And it's important to start with the intention to seek the solutions in nature. Start from the very, very beginning and get to that question. Get to the question that you can go to nature and ask. And it's also important to look at the whole system and the context of the challenges. If you think back to the slides that Carol did with the earth and the operating conditions, we can't just take one context. We need to look at the whole system in order to develop sustainable products. And here's a really important one. It's quieting the human cleverness. So often we go into a problem solution pretty much thinking you know where it's going to go. If you think of the Gojo example, what they did is they stripped away all that of what they thought they were going to know going in and started at the very beginning. They quieted their cleverness and they opened themselves to lots and lots of different models for innovation. And importantly, we have to ask different questions and we have to ask questions differently. This is a really important part of being in the mind of a biomimicry thinker. So if you think back 2 slides ago, where we had the refinery and we had the forest, one is a product of the 20th century thinking, which is the refinery, right? It's simple and it's disconnected, it's linear and wasteful, and it was produced and created for one thing, and it did not maximize more than one goal and was extracted. And with a different mindset in the 21st century, we can approach innovation differently, like the way the forest does, or the way another ecosystem operates, which is complex and interconnected. It doesn't create toxins, not that ones that are long-term. The whole system is optimized. It's very, very adaptive and regenerative. So we need to start to ask questions in a way that we can query biological systems for solutions. So Gojo was faced with, how do I reduce this hand sanitizer down to 2 batteries? But you can't go to nature with that. But what you can do is go to nature with, how are fluids moved efficiently and effectively? And so these are some of the questions that we can go to nature and get all kinds of answers. How does nature create color? More times than not, it's structural and it's not by laid on color. How does nature manage temperatures or change shape or navigate? There's all kinds of, this is just a very small example of the questions that we can ask. And going back to this idea that it needs to be a cross-cutting mindsets at the design table, these are just some. It's imperative that we have biology there and engineering. Business could be really important if you're talking about a supply chain issue or procurement. Design is really, really important. You know, just under biology alone is entomology, ornithology, horticulture, all the life sciences that you can think of. But also, we could add architecture to this, and chemistry and physics, all depending on what the problem is you're looking at, what the challenge it is you're trying to solve, dictates and helps invite in different minds across disciplines. And these might be some of the pressures that your business is facing. You know, you've got regulation is changing and customers are asking about sustainability and about your business practices. Supply chain, the whole scope 3, you know, if you're the big customer and you want to know from your supply chain what's going on, biomimicry can help them reduce some of their emissions and be more effective and efficient. The investors are asking lots and lots of questions, you know, before they will invest. And then there's enhanced risk management, which is becoming a really, really big deal, not just to supply chains, but just to the facilities that people are operating in and of themselves. And if your company or your organization is following and interested and signed up for the United Nations Sustainable Development Goals, biomimicry directly addresses at least 9 of these. And so it can help move your goals forward. And Fortune magazine identified this as a trend to watch. It said, if you're not incorporating the most brilliant ideas from the natural world into what you sell, you're leaving money on the table. So biomimicry is a way that we can have a healthy economy and a healthy environment. And now we can open up into questions.
Great. Thank you so much. That was such an interesting presentation. Some beautiful photos in that presentation too, and really fascinating examples. So thank you very much. I do want to kick off the Q&A with some questions that we have already received that came in with the registrations. And I know that there were a couple that were interested to know about specific industries. And so I'll start with the one around the built environment and architecture. So first, can you touch on biomimicry in the built environment? And how does biomimicry in architecture impact human wellness and connection?
Yeah, well, I can take that first, and I'm sure Carol and Peter will have something to add. There's many examples of how biomimicry has influenced really good building. One was we have an international conference, and we had an architect come and talk about his building in the Sonoran Desert, and it was fashioned after the saguaro cactus. And it's the way that the fins of the saguaro cactus are deep, and what it does is as the sun moves, it casts shadows along the cactus, and that's how it can survive this harsh environment. So they built some fins up on this building to shade it, and they've had spectacular results. There's examples of a building in Africa built after a termite mound. You know, termite mounds are built in extremely hot conditions, but yet it's cool inside, and they have built channels up the side for air circulation. And so building was fashioned after that. And then regarding human wellness, you know, that's where you get kind of into the biophilia. So two things. First of all, for example, the building in Arizona, the air exchange, that fresh air exchange in that was very high, which is really good for human habitation. And so that's one example, but also when you are designing and bringing nature into a space, whether it be through a viewpoint or whether it be through fabrics and materials on the wall, that's called biophilia. So the two are kind of related. There's been lots of research, especially in hospitals and healing, that it's a really important thing to do.
I want to add something about more water-based. So, you know, there's the idea of, oh, we should put green roofs on buildings and communities. And that is a great idea. And it also starts to be a building block for healing a waterway. So if you start to mimic how a forest manages water, that the rain comes down and the forest will slow it down, let it absorb. And as it goes along its way to the river, it's cleaned. And if we could think of a series of green roofs that is a way to slow water down in the urban environment and clean it along the way through a natural process, you can have both a building that's needed and be managing water in a healthy way.
That's great. Thanks. Peter, did you have anything you wanted to?
Well, I'll just reiterate something that was already mentioned. There's the whole side of materials. The example of Helicoid Industries, basically lightweighting a very strong and especially tough material has application in lots of different parts of the built environment. There are other things that are in development, have been rolled out, and that are probably going to be deployed more over the next half century. Having to do with creating concrete that, instead of adding CO2 to the atmosphere in its production, actually captures CO2 using models from ocean organisms and their recipe for making a hard cementous-like material.
Excellent. Thank you. And I wanted to go back to something that Tricia had mentioned, the difference between biomimicry and biophilic design. That was a question that we had. Can you just touch on that a little bit more and sort of clarify the difference between the two?
So biomimicry can be used for anything, not just buildings, right? It's as Peter said, in concrete, or some of the examples that Carol gave. Biophilic design is really about surrounding yourself with things that connect you to nature. Peter, did you have something more to say about that? I'm sorry, I feel like I stepped on you.
No, I'll go ahead and finish. I'll add something if you like.
Yeah, no, go ahead.
Well, I mean, there's a great book by E.O. Wilson who coined the term biophilia, and it is literally what Tricia is talking about. It's the theory, the hypothesis that we are somehow innately connected to biology and biological systems because we are of that source. Now, that is probably a very important ingredient that can drive the motivation, inspiration, and energy of people practicing biomimicry, which I would say is the sort of one kind of action one might take, feeling empowered by biophilia. That is, what can we do practically to make our world better using things that we can learn from biological systems? So they're not synonymous. They clearly are interrelated. But not in any one particular way. It varies. It will vary from person to person.
Great, thank you. Yeah, so it's just so fascinating. And so from the presentation and what you've discussed already, like biomimicry clearly has positive results. So why aren't we seeing more companies use it? And can you touch on maybe what some of the roadblocks are for companies to incorporate the application of biomimicry?
Well, I'll start with that one. That is a good question, Laura. And part of the problems are, companies have innovation processes that they're comfortable with, their staff is trained in, and when we started this effort, we used to think, oh, we're going to go into a company and change their innovation process. Well, that was something we had to evolve and not do anymore. What biomimicry can do is it can be added to an innovation process that a business has. And I think with that change, it could be more companies would be amenable to it. And there's also the problem that you learn how to do something, and that's what you do every day. And if you don't have that kind of mind that is like, oh, I have a little bit of time, I have a little bit of mental space to open and see something new, that's good. And the third thing is sometimes we don't know if a company's used biomimicry. They certainly don't have to tell us. And there's actually 40 places around the world where people are looking at biomimicry, but they want to keep it quiet so that their competitors don't know. So those are my ideas on it.
Yeah, that's interesting. Yeah, it's public information, but companies don't necessarily maybe want to
Right.
share that sort of advantage point of using nature in their design process.
I would add one thing that I think the timeline of biomimetic innovation does not sync well with the timeline of many companies and their innovation processes, because it can be messy. When you're bringing all those different minds to the design table, which you're not used to, we're used to just going to engineering pretty much, right? But now we're backing up and we're taking like 3-4 giant steps backwards, not in a negative way, backwards to envelop these other minds. It takes longer and it can be kind of messy. And So sometimes I think it's like, well, I need this done in 6 weeks, right? We need this to get this product in, out there in 12 months. And biomimicry does take some more time. And, you'll remember the slide about the mind of a biomimicry thinker. It requires some different thinking that can be done. It's a process.
Hey,
Yeah, and
Peter. Oh,
oh,
Peter, how long did Emily's project at Gojo take? I mean, she had that set up that it was pretty quick, right? Because then,
Yes.
Tricia has a point, and then there's other companies that do it quickly.
Yeah, I mean, I would say that what in that case study, and you can read about it, actually, the time to getting to a solution that was led to a prototype and it's something that was eventually rolled out was not very different from their typical process.
Oh, okay.
And it was cheaper to do, as it turns out. And that's all published. But I guess what I would say is, it's also important to have a little bit of historical perspective. So, biomimicry is not new. Airplanes are the result of biomimicry. That is an enormous dimension of our current lives. If you think about that innovation and how it transformed our world and continues to do so, you might understand that biomimicry actually has been going on around us, and it's not necessarily that limited in its examples. There are other examples in computing and elsewhere where we're not necessarily aware of those transformations that have changed our lives.
yeah, and Peter, being with the university, is biomimicry being incorporated across different majors? Like, how would students wanting to get into a career with biomimicry, like where would they get some hands-on experience through their university courses and opportunities?
So at the University of Akron, which is probably similar to maybe, I would say, 15 to 20 other universities in the United States in some ways, about the access to biomimicry as a training path. Students get this topic as part of classes or full classes in the College of Engineering, as well as in the School of Art, as well as in the College of Arts and Sciences, across multiple departments within each of those organizations. And that's sort of how it's built many places where there are things like undergraduate certificates, master's programs at various places, et cetera. It's still a small footprint compared to other programs that are much more deeply and historically established. But it's there, and students can find those paths.
And I would suggest, I've heard a conversation around actually the world that biomimicry, there's there's few companies who are looking for biomimics, but if you had that in your skill set, like if you were an engineer that also knew about biomimicry, if you were an industrial designer I understand biomimicry, it becomes a differentiator on your resume. And I think that's important for a student to know.
Yeah, so really embedding that skill set into a broader area,
Right.
like engineering.
Right. Yeah.
Great, thank you. I'm going to move to a question that came in from Kai. And it's asking about some examples of companies that have started a process of a factory as a forest beyond interface. But then there's sort of a follow-up question about how can we move to the systemic understanding in urban planning to resemble the ecosystemic function of the forest ecosystem? What would that entail for human system management? How can we imagine approaching that?
Well, after spending 23 years in city and regional planning, I have a soft spot for that question. And it takes much longer than the time we have here, involving political players, involving infrastructure. It is, I think, the ultimate goal for a living urban place. What was the first part of that question?
The first part was some examples of companies that have started
Oh,
process of factory as a forest beyond the interface.
beyond interface. I personally don't know of any.
Yeah, I think maybe biomimicry 3.8 is working with Ford Motor Company to do something
Oh,
similar,
right.
but we don't have any details on that. Yeah. So the whole, like, what Interface wanted to do was build a new factory. So they looked at the land, they quantified and categorized the ecosystem services that were happening on that land. And then when they went to build build the factory, they wanted it to replicate the ecosystem services of the forest, which is really kind of a cool idea. So yeah. And then urban planning, Carol and I are both urban planners. Yeah, that would be the ultimate dream. And I think the way to do that is get a lot of young people in urban planning studying biomimicry and then just pushing it into the organizations, because it's bumping up against a lot of really heavy things like, regulation. The Ohio Department of Transportation can't just say, oh, that's a really cool idea, let's do that. It's got to have, years and years of engineering and testing behind it. And so it will take a while, but it's a very good idea.
And run for office.
And run for office.
That's right. That's yeah, important too.
Mhm.
Peter, did you have something you wanted to add?
Well, I would just say I think it's important to acknowledge and recognize even where pieces of that larger goal are achieved. So, I mean, in our own region, right, we have breweries like Great Lakes Brewery that are actively seeking out wastes of from other
Mhm.
sources to be used as resources for their own work and vice versa, right? So where we might not get the full closed loop in every single aspect of some companies, we get the application in important parts of what they do, and that's aspirational to be even better, and it also provides examples and pathways to think about those streams in new ways, waste and resources.
Yeah,
Yeah.
that's a good point. We also have an organization called Rust Belt Riders that goes and picks up compost from restaurants and all that kind of thing. So you're right, there are bits and pieces of it that we shouldn't forget about, for sure.
Yeah, and with the Council of the Great Lakes region, I mean, we certainly want to draw attention and highlight some of those examples, because I think that it's really important for others to be aware of those success stories and what can be done to serve as inspiration and motivation to get others to also implement the important practices around sustainability and biomimicry.
Mhm.
I want to move to another question that's just come in from Paul. He states information about wetlands has been used to create man-made wetlands for stormwater management, including purifying water. Um, he asks, has this approach been applied to wastewater treatment that you're aware of?
I think it has
Um,
in Seattle. Yeah. Sorry, Carol, go ahead.
no, that's fine. I was thinking of that building in Oberlin that is the Peter B. Lewis Center at Oberlin College. Um, that is an example, at least for that building, how the wastewater is treated and recycled. Yeah, other than that, I don't know. And there's other people that might.
Yeah, I mean, and those are, and there are more examples, smaller, I think, and larger scale than that in our region and elsewhere. But also, it sort of bridges another possible not difference, but diversity of approaches So sometimes the wetland approaches are referred to as nature-based solutions. And that sometimes is regarded by some as something different from biomimicry, and whereas they're not necessarily the same, there's the same thing where there's lots of overlap, right? So building or restoring a wetland to provide the functions of, say, water purification and reclaiming for, re-input back into human use, is using biological organisms and those interactions to achieve the objective. And some people would say, well, that's not biomimicry, that's bioutilization or something like that. On the other hand, understanding how the wetland does that and what the species are and what those interactions are and how it can be leveraged does involve the very same process of understanding how a biological system works and then using that to solve problems that we have. So they're not distinct, in my opinion. They're related. There's overlap, and what they have in common is more important, I think, than how they differ. Anyway.
Yeah, that's a really good point. Thanks for adding that. In terms of waste, so there's no, this came in from one of the registrants about there's no waste in the natural world, and asking if you can highlight any examples with biomimicry that demonstrate that characteristic. I think there's probably something you've touched on in your presentation.
Well, I think that just about everything in biomimicry is that approach. I would invite the participants here to visit a website called asknature.org, and you can type in any question you want, and you'll come up with maybe some research papers, maybe a company that's approaching something in what you want to do. But it's a good place to start with some of these questions that maybe Peter and Tricia and I don't have those examples right at our fingertips.
Just as a biology nerd, I would add something, but I'll let Tricia go first.
No, where I was gonna go is say, I bet Peter's got an answer for this, because when she used the word always and never, your voice comes in my head of like, no, it's not usually always and never. So
yeah, right. So I think it's worth thinking about that question from multiple perspectives to get different insights. So, when we say waste, what that might mean is that the way that biological systems make things, they can be degraded and reappropriated and reused in lots of ways that our systems don't mimic at all, right? So it's not so much, you might think of it that way, it's not really so much that there's no waste, it's that the materials that are used are usable by other organisms, other parts of the same system where they share those resources at different times on different time horizons, right? The other thing is, waste is a real idea. We're animals called endotherms. We have warm bodies, and the work that our bodies do creates heat, which a lot of biologists think of that as waste from the work that's done, like that we physically do. That waste is used to heat the body, which provides all kinds of new benefits that distinguishes us from all other kinds of animals that don't do that and produce that waste. So it's a complicated term, but if you take a step back and think about it a little bit more deeply, you might get more insights into what is waste, why do we have waste, and waste is how is waste different from resources, etc.
Yeah, that's a great point. It's a circular system.
Yeah.
Well, unfortunately, we are out of time. So thank you, Tricia, Carol, Peter, so much for this very eye-opening presentation and this informative hour. I'm really intrigued by the application of biomimicry. I would love to see more nature-inspired, sustainable product design. So I will throw out to our audience, if they have any examples, any case studies from the Great Lakes region that they would like to share, please send them to us. So always great to hear about it. We can feature it through our platform and just make others aware of it. So that's just sort of a call out to our audience. A post-webinar survey will be hitting the inboxes of our audience soon. So if you could please fill it in and provide feedback, your input will help us improve these webinars and also guide us to make sure that we're touching on the topics that are important to you. Also, a recording of today's webinar will be sent out by email next week. And next month's webinar is on May 2nd on industrial sustainability. So I hope you will sign up for it, as well as join us in Toronto for the Great Lakes Sustainable Growth Forum in June. So thank you everyone for attending. And again, Tricia, Carol, Peter, thank you again so much for sharing your knowledge and expertise with us.